We will discuss arrays concept using Raptor and Dr. P.V. Sena from CBIT. The basic symbols used in this video is including this input, output and processing symbol. We are using a loop. So in order to maintain our array values, we are using this loop. This red diagram will represent this loop. Idea behind this arrays. Suppose if you read any 4 scores or 4 subject marks and display it. Suppose if your n value is 4. So what is your logic? So the logic is here's human sequential thought. So what we are doing here is we are declaring the 4 variables n1, n2, n3 and n4. In these 4 variables, we are storing these 4 subject marks. So suppose if I am increasing this 4 value, if I am reading 40 in case of n value 40 I am taking, then what is your idea? So you need to take the variables n1, n2, n3, n4 up to so on n40. In this 40 variables you can read the values and display that. So now I want to test your patience. Suppose my n value here it is 4000. Yes. So in 4000 scores I need to read and display it. So what is your idea? You need to declare the variables n1, n2, n3, n4 up to so on n4000. Instead of doing like this, can you think the better strategy? Is there any other alternative possibility? Yes, there is a provision. The hint is, so 4 scores in 4 subjects, you need to declare the scores, the name only once and with a different indices 1, 2, 3, 4 up to so on the n value. In this particular memory locations, you can store the values. So here the strategy here it is. So you need to declare a contiguous memory locations. So if possible, create a contiguous memory locations with a single name. Suppose the array name is A. So now here we are creating this contiguous or continuous memory locations with indexes 1, 2, 3, 4, 5 up to so on 4000. So always in Raptor the index starts with 1 only, not with 0. Always the index start with 1 only in Raptor, not with 0. Index here this will be there. So the values at this particular memory locations you can store in this contiguous memory locations. So always the indexes I comma j will represent the indexes. This point is very clearly remember. I comma j will represents the indexes. A of I comma A of j values represents the values at that memory locations. Assume the array name is A. In this case, so what is array? Array is a collection of similar data types, similar values, and homogeneous data values. So array is a contiguous or continuous memory locations where we can store the similar data values. So always I comma j will represent the indexes. A of I comma A of j represents the values at that memory locations. Assume that A is an array name. A is an array name. The index 1, 2, 3, 4, 5, 6. So values at that indexes are 66, 77, 88, 99, 98, 100. Assume these values. Always I comma j will represent the indexes. A of I comma A of j values will be represents values at that memory locations. The following figure shows it. So now we need to develop the algorithm to read any 5 numbers and display it. Initialize the variable I is 1 for the index. Why not 0? Here the index starts with 1 only in Raptor. So I is a variable which is initialized to 1. So I need to read any 5 values. For that the condition becomes to I greater than 5. So 1 greater than 5, this condition is false. In Raptor only the condition is false, then the loop goes to execute. The remaining programming language, if the condition is true only, the loop goes to execute. The loop controls the number of elements in the array. So read the values A of I location. Yes, the read the values in A of ith location. That displays the values in A of ith location. So in order to read this value, first you need to read the number n and assign this number in A of I. So first you need to read the number and assign this number in A of I. After that one, you need to directly display the value set in A of ith location. Then you need to increment the I value. Repeat this step. Repeat these steps down. Next, repeat from the step 2 until the condition becomes true in case of Raptor only. So after this one, end of this loop. This is the algorithm where we are reading any 5 numbers and display it. So it's equivalent flowchart I developed by using this rapid algorithmic prototype tool for ordered reasoning, Raptor tool. So what I did here, it is first I am reading n value. My n value is 5. So I is a variable which is initialized to 1. The array numbers are I am displaying. This is the prompt. For this purpose, the array numbers are only for labeling purpose or prompt purpose. So the loop enters. So I is greater than n. 1 is greater than 5. The condition is false. Then I am reading the number. After reading this number, I am storing this value in a of 1th location. So next, I am displaying this value. Next, I am incrementing this index location. I is I1, I becomes to I plus 1, I value becomes to 2. So next, 2 is greater than n. Condition again false. Again, I am reading some number and a of second location I am storing. Then I am printing value to a of second location. Next, I value becomes to 3. I value becomes to 3. So now again I am checking this condition, 3 greater than 5. 3 greater than 5, this condition is false. Again I am reading the number. Of third location, I am placing these values. After that one, by using this put output statement, I am displaying the values at a of third location. So next, I value becomes to 3 plus 1, 4. I value becomes to 4. 4 greater than 4. 4 greater than 5. Condition is false. So again, I am reading one more number and I am placing a of fourth location. A of fourth location. I am displaying the values at a of fourth location. So next, I value becomes to 5. So now 5 greater than 5. This condition again false. 5 greater than 5. Condition false. Then again I am reading one number by input symbol. Then after that one, this number is stored in a of fifth location, array of fifth location. Next I am displaying the values at fifth location. Next, I value becomes to 6. So 6 greater than 5. The condition is true. Then it will come out of this loop. So these are the output values for my arrays. So in this way, you can try to find the biggest of given n number, the smallest of given n numbers. So search the given element is present in the list or not. So sort the given list of elements. So you try to find out these elements. If possible, you need to try to feasible solutions, all the possible solutions. In that possible solution, you need to find out the best one, the optimal one. Optimal strategy is the best strategy. Thank you, children. Thank you for listening.